In today's lesson, our objective is to be able to algebraically solve for velocity, displacement, position, or time when given the other variables or the other inputs. This is our learning target number 5 within Unit 2. Last week, we talked about how to calculate both speed as well as velocity. So a lot of times you will see speed written as an equation where S stands for speed, D is distance, and T is time. All right. Remember that speed is a scalar. There is no direction associated with it. Just has a magnitude where it is the ratio of distance covered over time elapsed. Now, velocity is a little bit more complicated because it's a vector and it does include direction. A lot of times you will see it written this way, where the little bar above the V stands for average, and this would be equivalent to displacement over time. Now, the way displacement, though, is symbolized, right? If you see over here, displacement is a difference in two positions, right? X stands for position. And a lot of times this will be referred to as delta X, which means the change in position, which would be equivalent to an object's final position minus its initial position, right? So written out fully, right, your average velocity is your displacement over time. But once again, as said earlier, displacement is your change in position, right? Now, it almost makes sense to just try a few examples with this and utilize and work with this average velocity formula. So for instance, say we had an object along the number line, right? And say that this is a location of 0, 1, 2, 3, and so forth. Okay. And say we had an object. I'll do a different color here. Say we had an object starting here. It's like our ghosts, right, from the little Pac-Man interactive. Okay. And say that this ghost moved from this location back to this location, and this occurred in 1.5 seconds. So there's no algebraic manipulation here. If we wanted to solve for the average velocity, our final position here is technically -3 meters, and we would subtract its original position, right, its initial position, which was +1 meter, and take that entire thing and divide by the 1.5 seconds of time elapsed. If you do the numerator here, you will get that you went 4 meters backwards, hence -4 meters in 1.5 seconds. So if we were to divide those two, I believe here we would get -2.6 repeated meters per second for our velocity. Okay? We can do other things, right? If we start with our average velocity formula again, we could solve for other things. For instance, say we were on the football field and someone ran from the 20-yard line up to the 38-yard line, right, on the same side of the field. And let's say that they were moving at 5 feet per second. So notice here, we've got our initial position. We almost have to identify what we have. Here's our initial position. Here's our final position. This is our average velocity. Notice our units almost give it away, right? So in this case, the question is, how much time goes by? So we can work with this, and here's our unknown variable, right? So we can plug things in. So we have 5 feet per second, right? This technically is positive. Our yardage is going up, so our position is increasing. This would be equivalent to the difference, right? 38 yards minus 20 yards over our unknown variable, time, which is what we're solving for. Now, if you notice, we have some issues with the units here, right? So we can do one of two things. We can either change our displacement into feet, or we can change our velocity into yards per second, right? I'm going to elect to change this, right? Because when we subtract those, we're going to get 18 yards. And we could do a little unit conversion practice here, right? In 1 yard, we have 3 feet. So this entire displacement is going to be 54 feet, all over our unknown time equals 5 feet per second. Now, in order to solve for time, we just need to multiply by time on each side. Time goes away on the right side, right? And then if we divide by 5 feet per second on each, this will cancel. And notice the feet will cancel. 54 over 5 would then give us just the units of seconds remaining, which is a time. So in this case, t would equal, I believe, 10.8 seconds. So the key thing is, if you are detailed and organized enough to identify the variables that you have and the one that's unknown, then you can use some algebraic problem solving skills to solve for unknown quantities.